No one knows for sure what dark matter is, and that has physicists and astronomers scratching their heads. Scientists design tests to try and figure out what it is, but no one knows exactly what composes dark matter. Dark matter is of great interest to physicists because it explains how the universe came to be, as measured by the distribution of gravity among galaxies. A group of scientists looking for answers concerning dark matter has stumbled into a gateway of the fifth dimension, which will fundamentally alter our understanding of the cosmos. Want to know the details about it? Stay with us to the end of the video. There's a lot more information to be revealed. Despite making up most of the universe, dark matter has long baffled physicists and astronomers, who have yet to crack its code. The remaining 75% of dark matter has been speculated to be explained by the fifth dimension. In spite of this, many of our presumptions about the cosmos' physical properties rest on the notion of dark matter. Scientists think this because dark matter makes up a majority of our cosmos and is regarded as pinch runner that helps scientists appreciate how gravity works. They assume that, absent the X factor of dark matter, certain features will disintegrate or fall apart. Even so, dark matter has no effect just on the particles we see and touch. This means that it must have other distinct qualities, which is why so much research on dark matter was needed. A group of physicists from Johann Gutenberg University in Mainz, Germany, did a study in an attempt to understand more about dark matter and its properties. This investigation provided an idea involving mysterious particles flying around in a secret fifth dimension. According to their research, this particle's gravity may manifest in our four-dimensional reality as an additional gravity we currently assign to dark matter. The discovery, which was reported by the European journal C, claims that the particle can provide a credible explanation for dark matter. This phenomenon has never been officially explored, yet it is believed to account for a bulk of the universe's overall mass. According to the study's authors, particles are capable of traversing the whole universe, including the recently discovered fifth dimension. For decades, researchers have questioned the veracity of the three spatial dimensions, i.e. over and under, left and right, back and forth, and the fourth dimension, i.e. time. An extensive study by scientists has led to the development of fifth dimension equations, which reveal the effects of an extra dimension could have on the cosmos, and maybe even on the fabric of reality itself. Adrian Carmona, Javier Castano Ruiz, and Matthias Neubert, the study's authors, all agree that finding evidence of a fifth dimension was unexpected. An early motivation for this study was to shed light on how fermion particles might have risen through the system with a twisted extra dimension. But as they probed the connections between five-dimension equations and fermion particle masses, the scientists uncovered a new scalar, which had previously only existed in sketch form. This recently discovered scalar is related to fermion particles and claimed to be very similar to the Higgs boson particle and Higgs field, both of which are described essentially by their magnitude. They found the new level of field scale had peculiar and fascinating behavior in addition to an additional dimension. We believe the existence of these heavy particles would join the visible matter that we know and that constitutes dark matter have been studied in detail, researchers said in a statement following the binding. This belief is based on the assumption that dark matter is composed of fundamental fermions that live in the extra-dimensional realm. According to the study's authors, the heavy particles could serve as a new form of communication with the dark sector. In dark matter, astronomers recently used the Hubble Space Telescope to look at 11 galaxy clusters and found that they create 10 times more gravitational lensing effect than cosmological calculations predict. This finding suggests that dark matter may be more prevalent than previously thought. Dark matter halos are larger and denser than anticipated by the current cosmological model. Therefore, scientists have researched the phenomenon and came to this conclusion. In 1933, Swiss astronomer Fritz Zwicky of the California Institute of Technology noticed something peculiar while observing the Coma galaxy cluster. As far as the visible mass could tell, the individual galaxies were traveling too quickly for the cluster to stay unchanged. The immense gravitational attraction that holds galaxies together can only be explained by the negligible amount of dark matter. After extensive research, scientists dubbed the substance black since it neither gave off nor absorbed any light after the initial meeting. Only through gravitational interaction with everyday matter could its existence be disclosed. This dark stuff has been studied more extensively since then. Evidence from numerous studies indicate that this particular phenomenon constitutes roughly 75% of all matter in the cosmos. Within the standard model of the universe, it is known as cold dark matter. The nature and composition of cold dark matter are still mysteries, but it's theorized that it's composed of weakly interacting massive particles. In this CDM model, a hierarchical structure is formed from a gravitationally bound dark matter halos. As the largest system merged with smaller ones, they would create these dark matter halos. This hierarchical structure of dark matter halos would result in larger halos containing smaller substructures in the form of embedded subhalars. Similar structures can be found in groups of galaxies called galaxy clusters, which consist of hundreds of galaxies organized into smaller dark matter halos. Careful observation and theoretical investigation with cosmological models reveal the evolution of these galaxy clusters as a result of the interaction of luminous and dark matter. Scientists may now evaluate the validity of the standard cosmological models thanks to these findings and comparisons. Clusters of galaxies are the most fundamental structures in the cosmos, and their combined mass can be greater than a quadrillion suns. By applying Einstein's general theory of relativity, we can see their massive bodies bend and even split the light from faraway galaxies. These occurrences can only be observed thanks to a technique called gravitational lensing. Gravitational lensing allows astronomers to map the distribution of both normal and dark matter in a dense cluster. Understanding the idea of gravitational lensing is straightforward. Scientists need to back-calculate the observed image distortions to find the lens's mass distributions. In a recent Hubble Space Telescope observation, 11 massive galaxy clusters were found to be lensing tens of galaxies. Thanks for watching. If you have any questions, let us know in the comments section. Also, at last, give a like to this video. See you soon.